3 questions. You know some stuff from that. What do you know? What's that? That's an X. What's that? That's a Y. What's that? That's the line we have. Do we know something about that line? I need a slope that is parallel to that. What do I know about parallel slopes? Parallel slopes are the same. Equal. So, if I know this slope, do I know the slope that goes with this line? Yes. But I got to get this slope first, right? Yeah. How do I find that slope when it's in standard form? Barf. What do I got to do? Convert it. How do I convert it? Which form gets me a slope automatically? Slope-intercept. How do I put something in a slope-intercept? What has to be isolated? Y. 4y equals negative 2x plus 7. Y equals negative 2/4 x. We would never leave it as that slope. What is it really? 1/2. So the m with which I am dealing is 1/2. Now, do I have a slope? Do I have the slope of this line? Yes. Do I have a point? If I have a slope and a point, do I have an equation? Which equation? I got point. No. I've got a point and a slope. He emphasized 2 words specifically. Point slope form, which is y minus y1 equals mx minus x1. Where is the point that I know? Y1 and x1. So, what do I write here? Y minus what? 1 equals, what's my slope? And x plus 3. Because technically, it's x minus minus 3. Right? Oh, it's so nice to see all of you correcting your homework. Yeah. So spectacular. Boy, somebody should pass me the paper towel roll because I need it to dry up all my tears of joy. I just don't know why I don't do better in math class, Mr. Myers. It's a complete mystery to me. There's no reason for it. I often find myself wondering why I'm not in the Olympics for skiing. I think you know. Because I'm old, fat, and don't practice. You guys are neither old nor fat, so it must be that you just don't practice. Practice. Who needs to practice? You guys are millennials. You're good at everything. You're going to graduate high school and earn $100,000 a year and buy your own house. Of course you are. Everybody knows that. You're not going to end up homeless. You're not going to half of you aren't going to end up homeless because your parents are going to let you live there until you're 110. Yes. What 7? You don't need the 7, Ayaka. This is the other line. All you need is the slope from that. All right. In the next one, what is that? A known point, an x and a y. I need to find that point, but on a line that is perpendicular to that. So what do I have to do to the slope? What are perpendicular slopes? Opposite reciprocals. So again, I don't know what to do. But Mr. Myers has said 1,000 times in these last 3 units, if you don't know what to do, find what? Slope. So the first thing I do is I find my slope. X plus 8y. Do I even need to care about the 5? Why not, Evan? Because you're right. I don't care about the 5. What's the only thing I need from this thing that's highlighted in yellow? I need the x and the y, because that's what's going to tell me the slope, because slope is made up of x's and y's, isn't it? Yeah. So all I got to do is find the slope. So I don't even care about the 5. To find the slope, y has to be by itself, correct? So x would jump over here and become negative x, wouldn't it? And then how do I get rid of that 8? I divide by 8. So my slope is negative 1/8 x. But I don't need that slope, do I? What slope do I need? I need the opposite reciprocal slope. What's the opposite of negative 1/8? Just the opposite. Positive 1/8. What's the reciprocal of 1/8? 8. So the slope I need is positive 8. Now, do I have a slope and a point? Yes, Michael. I don't need the x. It's just the slope. Do I have a slope and a point? Can I write an equation? Which equation? Point-slope form, which we are going to use again. Y minus what? It's y minus minus 2. So what do we actually write? Y plus 2. To remind you, which I will write in dusty rows, it's y minus minus 2. The negative 2 goes right there. Equals, what's our slope? 8x minus 3. And there's our answer. And finally, the equation of each line. What are your options for writing equations? How many choices do you have? 4. Slope-intercept, general, standard, point-slope, correct?
Which one of those does it fall under where it's horizontal or vertical?
We'll get to that when we get to it. A is an oblique line, which is the $5 way of saying diagonal. So the first option I need to do is decide for A what form I am going to use. It's on a graph and I can see it has a slope. So right away I should use either slope-intercept or point-slope, correct? Let's check. Is the intercept an exact number? No. So can I use slope-intercept? No. What should I use then? Point-slope. And to do point-slope, I need to find 2 things. The slope and any point on that line. Where on this line can I find a point? Tell me when to stop. There's 1. Now I need another point to get the slope, don't I? Tell me when to stop. My slope is rise over run, which is 1/4. Slope equals 1/4. Now, did I not just find 2 points? Does it matter which one I put in point-slope form? No, I can use either one, can't I? What's this guy? -2, 3. Is that visible written in gray? No, that's horrible. Let me fix that up for you guys. That point, -2, 3. Is that a point? So could I use that here? -2, 3. Is that a point, which is 2, 4? Could I use that here? So both of them would be correct. If I use this one, what's it going to be?
Y minus 3.
Minus 3 equals 1/4
Right. Might as well do the second one while you're waiting. Then at least you'd have done something on this page. Oh, that's the blue one. Y minus 3 equals 1/4 x plus 2. Or y minus 4 equals 1/4 x minus 2. Alrighty, now B. Does B have a slope?
Yes.
It does. Does B have a visible y-intercept that is exact?
Nope.
B. No. So what should I do? Point slope again. There's a point. There's a point. The slope is 3 and -2. So the m is -3/2, and I have 2 points. Does it matter which one I use? No. -4, -1, and -2. -4. I can use either one. So it's y plus 1 equals -3/2 x plus 4, or y plus 4 equals -3/2 x plus 2. This bothers my previous classes. It boggles your mind that you can have 2 different equations for the same line. But they're not really different equations, are they? If I got rid of all the brackets and collected all the like terms, what would I have? The same thing. Now, we get to Aiden's question. What do we do for a vertical one? There's C. Again, look at what I have there. I have a point, don't I? And what is that point? 5, 0, correct? What is that point? 5, -2. What is that point? 5, +2. What's the same? X equals 5. So what's D? D is up here. What's that point right there? 0, 9. What's that point? 3, 9. What's that point? -3, 9. What's the same?
So
Y equals 9. And finally, E. Do I have an exact y-intercept? What is it? -6. Can I find the slope? Sure. I can go right over to there. 2/7. Y equals 2/7 x minus 6. Everybody should have been able to do that. We are going to finish 233 right now, and then I'll tell you what we're going to do in a sec. This caused a lot of problems for people. What do I have right there? What is that? It's a general form equation, yes? Could we graph it right now? Yes or no? Why not? What about that equation makes it not okay? That right here messes us up, doesn't it? Have we ever been left with a K? No. So what I got to do is I got to figure out what K is for all of these. What are my options? What are my 4 options? Point slope, standard, general, slope intercept. Now, all 4 of those use x and y, don't they? All right. So, if I had x and y, could I find k? I can, because we know how to do algebra when we only have one letter, don't we? Okay. So, what do we know about the x-intercept of 3? Do we know something about it? We know that it's 3, 0, don't we? And isn't that an x? And isn't that a y? So where could I put that 3 in this equation that we don't like? For x. So it would be 3 times what? 3 plus 2 times what? 0 minus k equals 0. Could you tell me what k is now? 9 minus k equals 0. Bring the k over here. K equals 9. Is everybody with me? Is everybody cool? Because once I have an x and a y, I only have one unknown, right? Great. Do the rest of it. That's your work for right now. Finish that page. Then we'll talk about the rest later. You can work with a friend. You know you that did not bother to do them, you can start copying them down now. I'm sure it's been working out for you so far. I have an x and a y. I will remind you that it is 3x plus 2y minus k equals 0. Here is an x and a y. So, all I do is I work it out. X is negative 2. There's an x. 3 times negative 2 plus 2 times 0 minus k equals 0. 3 times negative 2 is negative 6. 0 disappears. K moves over there. K equals negative 6. How'd y'all do? Spectacular. What's different here? I got a y-intercept. So what is the point that I know? 0, negative 3. So that's my x, that's my y. So I go back to my equation. 3 times 0 plus 2 times negative 3 minus k equals 0. That drops out. Negative 6. K comes over. K equals negative 6. There's my answer. I remind us again, we have 3x plus 2y minus k equals 0. Y-intercept is again 0, 7. And I just fill it in. Are we at a point now where I can just do what I need to do? We know the x is 0, so we know that's going to drop out, don't we? So it's 2 times 7 equals k. 14 equals k. What is that? X. What is the negative 1?
Y.
Y. Do I have an x and a y in the equation? What do I put in? 3 times what? 2 plus 2 times what? Negative 1 equals k, because I've moved the k over, right? What's 3 times 2? What's 2 times negative 1? 6 minus 2 equals k. So what does k equal? 4. And lastly, there's an x, there's a y. 3x minus 2y equals k, because I've moved the k over. What goes in for x? Negative 4 minus 2. What goes in for y? 3 equals k. Negative 12 minus 6 equals k. What does k equal? Negative 12 minus 6. Negative 18. Is everybody good? That's the end of this little mini unit. So right now, in a perfect world, I should be able to give you any 2 points on a graph, and you should be able to graph them and write me an equation from them. That's for this unit, this little mini unit. For the last unit, I should be able to give you any equation of all 4, and you should be able to graph it. Right? That's where we are right now. Yeah? You have a test tomorrow on graphing. Not so much on being able to write the equations like this, but being able to take the equations and put them on a graph. Now I have a couple of questions on that graphing test, where if you can do this, it will be easier for you. Because I am not giving you a test specifically on this. Okay? When am I going to assess this? The next page in your book, page 224, is an assignment. That will be marked on Monday, because you're going to work on it on Friday. Everybody cool? Now you have a test tomorrow on graphing. Let me ask you this. The last unit, which is linear systems, the very first thing you need to do with linear systems is graph lines. So if I taught you that first lesson, you would get double practice graphing. Should we go ahead? All right. If you could all turn to page make sure I've got my page numbers correct. Does page 229 for you start with linear systems, written with a font that looks like rocks? Excellent. If everyone could go to page 229, I would be very happy. All right. A little bit of background first, as always, and then we will carry on with the first. There's 3 ways to do this. I'm only going to show you the first way today because the first way is graphing, so it reinforces our last 2 units. All right? A system of equations. What does the word system mean in English? Pardon me? A way of doing stuff. Absolutely correct. And Emily, is that way of doing stuff one step? If it was a system, or do you have to do a bunch of stuff? You got to do a bunch of stuff. It's exactly what it is in math. A system of equations is a related group of at least 2 equations. All right? Now, let me give you an example. Could we draw a line relating your ability to get a driver's license and your age? Could we do that? Yes or no? Could we relate your ability to get a driver's license to your age? Sure we could, right? When do you have the ability to get a driver's license? 16. Have you aged 16 years already? So you would draw a line that looked like this. If I was to do this line, age versus driving. Everybody agree? Okay. Your age would go up 1 year for every year you were alive, yes? So the graph would look like this. Year, because my years are passing too, aren't they? But my age is not the same as yours, is it? So for you guys, at 0, your first year of life, your age is 0, correct? Your age would go here, yeah? And after you've been alive for 1 year, you are 1 year old, yeah? Everyone agrees, yeah? So that line would go up until we got out to 16, right? That is your age versus the years we've been counting. Everybody cool? Everyone agree? That's one equation, isn't it? That's age equals years, right? Because whatever age you are, 1 is the years you've been alive. Agreed? When are you allowed to drive? 16. For everyone in BC, correct? So if I were to have another line for driving age, which should be coming up red, but of course it isn't. What is the driving age? 16, right? Are we counting 2 things there or just 1? Driving age. It's always 16, isn't it? Would that go on the age or the years scale? Age. And it would be 16, wouldn't it? Would it ever change? Maybe it might, but for now it isn't, is it? Everyone understand? So the black line, age equals years. The red line is age equals what? The driving age, which is what? 16. Is that an equation? A equals Y. Is that an equation? A equals 16. Is that an equation? So do we have a system? Everybody with me? 2 lines on the graph. They make a system. Everybody cool? All right. What do you know about a linear equation? Pardon me? It's a straight line. A linear equation is a straight line that has what characteristic? How do we know it makes a line? It's got what kind of rate of change, Wong? Pardon me? Same. Absolutely correct. A straight line that has a constant rate of change. Now, what's our shortcut word for rate of change? Because rate of change is 3 words. What's the one word that we use instead? That's 2 words. 3 words. Still, rise over run. What's the short word that we use to describe rate of change? Slope. Right? So, if a system of equations is a related group of at least 2 equations, and a linear equation is a straight line that has a constant slope, what must a linear system be? At least what? How many? At least 2 straight lines on a graph. That's it. Is everybody cool? If I got one line, it's just a line. If I got two lines, then it's a system. Or 3 lines, or 4 lines, or 5 lines, and so on, and so on, and so on. Everybody cool? All right. Now, to solve a linear system, what is every line made up of? Points. And what are those points? X's and Y's. So if I add a red line on my graph, every one of those points is an X and Y, isn't it? And every red X and every red Y works on that line, doesn't it? Okay. What if I put a blue line right there? What do I know about that blue line? What's it made of? X's and Y's. And every single X and Y on the blue line works in that equation, right? Which will show up in a second. Everyone agree? Well, what do you notice about that XY right there?
Same.
Is it on the red line? Is it? Is it on the blue line? So that must mean there is one X and Y, and I'm using purple because red and blue makes purple. One X and Y that works on both lines. And that is what it means to solve a linear system. You have to find the X and Y that work for both. Now you can see when we graphed it on a graph, it's the intersection. Is everybody cool? Does it make sense to everyone? Obviously, if this is all X's and Y's, and this is all X's and Y's, then that point there must be the single X and Y that is on both lines. Will there ever be another if the lines are straight? Will they ever cross again? No. Is everybody good? All right. I'm going to leave that up there for a second. We, today, are going to just do graphing. Because like I say, it helps reinforce what we did what you're about to get tested on. So, I've made the first couple ones very easy. Step 1, go to slope-intercept form. What is M? Slope. What is B? The y-intercept. Okay. Now, for this first day, everything's going to be slope-intercept because it works perfectly. But, am I locked into slope-intercept? No. Could I use point slope if I wanted? That's available to me if I want it. Could I use general if I want it? They're available to me. But for practicing purposes, we're going to leave everything slope-intercept, right? So we're going to get into slope-intercept form, then we're going to graph the line. Again, I remind you, graphing the line means, what do you do first? Do you care about the slope or the y-intercept first? The y-intercept. Dot for the y-intercept. Wherever it is. If it's plus 6, where's the dot going? Up or down? Up. What if it was minus 2. Where's the dot going? Down. What if there was no y-intercept? It was just y equals mx. Where's that dot going to be? I should have done that a different color. Let me do it green. Don't say it yet. Don't say it yet. Think about it. Where would that dot go? 0. Is everybody cool? That's step 1. What is step 2? Once you have a starting point, what is step 2? Count rise over run for slope. How many times do you have to do that if we're doing a system? At least twice. Good job. You're going to have to do this at least twice. And then identify the xy where the lines cross. The intersection is the solution. Everybody cool? All right. Let's do a couple of these. Turn the page over to 230. Pardon me? Of course not. I'm going to do this guy in red. Is that guy in slope-intercept form? Is he in slope-intercept form? No. Slope-intercept form means y is by itself and positive. Is y positive? So should we move him? We're just going to move x. Y equals negative x plus 4. Is that slope-intercept form? Excellent. Should I put it on the graph right now? Why not? I got another equation. What if I need fractions? I'll do this guy in blue. Negative x plus 2y equals 2. Is y by itself? Is y positive? Yes. So since y is positive, should I move it? No. 2y equals, what happens to that x when it moves over? Positive x plus 2. How do I get rid of the 2? Y equals 1/2 x plus 1. Am I now in my 2 slope intercepts? Now what do I care about? I'm going to the graph. Do I care about the slope or the y-intercept right now? For my first dots, I only care about the y-intercept. 1 is 4 and 1 is 1. There's no fractions, are there? So do I have to worry about scales or anything? Nope. I just got to put some lines on the graph. Doesn't matter where I put them, as long as I make axes. Everyone agree? Where's my first red dot go? Up, 1, 2, 3, 4. Where's my second red dot go? Down 1, right 1. For how long? Infinite. So if I went down 4 and out 4, I'd still be good, wouldn't I? If I went up 5 and that way 5, I'd still be good, wouldn't I? Or I could put a dot at every spot. Would it matter? No. Do I connect this line? Of course I do, because it's continuous. Everybody cool? Where do I put my first blue dot? At 1. Right there. What's my slope? 1 up and right 2. There it is. They both hit there. What is that value? Which I will write in purple, because red and blue makes purple. 2, 2. Now, how many of you have spare time? All of you put your hand up because whenever I say work, all of you do is talk. So you all have plenty of spare time. That 2 represents what? An x. That 2 represents what? A y value. What's that?
That's what? The X.
What's that?
The Y.
What should I do now?
Graphin.
Check it. Is 2 plus 2 4?
Yeah.
You betcha. Is negative 2 plus 2 times 2 is 4? Is negative 2 plus 4 positive 2? So did we do our math correctly?
Yeah.
Is it worth 1 second?
Yeah.
Yes. Will most of you do it? No. Because I gave you that same advice when we were doing factoring 3 units ago. And people were still handing me in factoring questions wrong. But I'm going to keep trying because that's what I do. Let's look at the next one. In red. Is that guy 3x minus 2y equals 12 in slope-intercept form? What would have to move?
Y.
You're going to move that y. 3x equals 2y plus 12. Now what do you got to move?
The 12.
The 12. What happens to the 12? Minus 12 equals 2y. Now what?
Divide 2.
3 over 2x minus 6 equals y. Could I graph that if I wanted to?
Yeah.
Should I right now?
No,
Why not?
because there's one more.
We don't know this.
We don't know the scale. So we go to blue and we work with this guy. 2x plus y equals 1. What needs to move?
2X.
2x.
The x. What happens to it?
Negative
Negative.
plus 1.
And now I can graph that. What's the numbers that I care about right now?
The Y intercept.
The y and the x intercept, or the y intercepts. Are either one of them fractions?
No.
No.
So do I care about scale?
No.
So I can just put my axes on, can't I?
Yeah.
Where's my first red dot going?
Down 6.
And what's my slope?
3. Go up 3.
3 up 3.
And right 2.
Right.
How long can I carry that on for? As far as I need to. And there's my line. Where's my first blue dot going?
1.
1. What's my slope?
2. Negative 2. So, go up 2.
Down 2.
Down 2. And
Down to right.
right 1.
Down to right 1. And there's where they cross. What is that purple value? 2, negative 3. Is it easy to check?
Yes.
What's 3 times 2? What's negative 2 times negative 3? Positive 6. Is 6 plus 6 12?
Yeah.
So were we right? What's 2 times 2?
4.
What's 4 plus negative 3?
1.
1. And we needed it to be 1, so were we right? Yes. Now, I am going to do one last one with you here because I want to show you something, okay? This is not part of grade 10, but it's part of systems, okay? All of you know what to do with that guy, don't you? This guy, 1, 2, 3, 4, 5, 6 of you know what to do with that blue guy. The rest of you have no idea, do you? Those weird vertical lines, right? You don't know what they are. You do, you saw it in grade 9. Those vertical lines mean that everything inside those vertical lines has no positive or negative value. It's not a vector. It's a scalar. Remember what that means? Right? Distance was a scalar. I moved 5 steps. Not positive or negative. I just moved 5 steps. Right? So if I wanted you to graph this, what would it look like? Would I still have an x and would I still have a y? I have x's and y's, don't I? When x is 0, y would be what?
0.
0. Because y equals x, correct? If those vertical lines were not there, and I put x as -5, what would y be? -5. If I put x as +5, what would y be?
5.
+5. Everyone agree?
Yeah.
But those arrows are there, right? So if I put a -5 inside those brackets, is the negative going to be allowed to stay there? No. So what would the y value be since the negative has to disappear? 5. Is everybody with me? Okay, I'm doing this not to show you absolute value, but to show you something else about systems. Can we graph this guy already? Keep that guy red. Let's make that guy blue. Do I have enough points to graph it? Is 3 points enough to graph? Okay, so I'm going to put a dot at 0, 0, correct? So I'm going to put a blue dot at 0, 0. Agreed? And I got to have a dot at negative 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. And I got a dot at 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. And that gives me this construction. They're straight lines, but I'm never allowed to have a y that's negative. Everyone cool? Remember, this is not part of grade 10. I'm just showing you something about systems. Everybody good? How do I draw the red one? Where do I put my first dot? 1, 2, 3. And what's my slope?
1, go up 1 and right 2.
Up 1, right 2. Up 1, right 2, up 1, right 2. And there I hit, right? But where else do I go? Down 1, left 2. How many times does the red line hit the blue line? Twice. So how many solutions are there? 2. And they are 4, 4, and what's this guy?
2, 2.
-2, 2. Now let's check. 4 is my x value. There's no negatives allowed inside there. Does 4 equal 4? Okay. Is half of 4, which is what? Plus 3 is 5. So I didn't do my graph very well, did I? 1, 2, 3, 4, 1, 2, 3, 4, 5. Check with the red one. -2 and -2. -2, does that equal 2? Okay. What's half of -2? Is -1 plus 3 2? So that one was okay, but this one was a problem, wasn't it?
I put 7 with 7.
Why? Why is this one a problem? What did I do poorly?
Well, it's
Did I graph it well?
No.
I didn't. So, what was my purpose here? We're on the very last graphing example, right? Why would I graph something that was difficult to graph and gave us a weird looking answer?
Go graph its other graph twice.
Is graphing exact?
Not always.
Is it easy to make a mistake? Is it easy to catch your mistake? Yes. Do you think I'm going to stop teaching you systems at graphing? Of course not, because graphing isn't exact. What if the graph gets really crazy? And don't write this down, but what if one graph looked like this and the other graph looked like this? How many solutions would there be? 2. Are they exact? No. So graphing has limitations. That's why I put this one last. Everybody cool? But the lesson for graphing is wherever the lines cross, that's your solution. And to make sure you double check. Everybody good? Because the real answer there is is 6, 6, not 4, 4. Because when I graphed it, I didn't go up dot by dot. I did do a couple of dots and did a line. Everybody good? All right, now listen to me. You have 20 odd minutes left in class. You have a test tomorrow on graphing, which you could be working on right now, getting ready for it. If you want, you can go ahead and work on the assignment that starts on page 224. That's going to be due Monday. You need work for Friday, though. So, for Friday, you are either working on page 224 or page 231. Now, if you work on page 231 now, 231 would be really good prep for tomorrow's test. But 224 is helpful too. So I'm leaving it up to you. Thursday's class, we will be going over Wednesday's test. Because I will come back to school and I will pick it up and I will mark it. Everybody cool? Everybody has something to do? 90% of you will ignore the fact that you have something to do, but that's on you. Everybody good? Go.